Hello everyone. This is the first part of the series. In this series we will see how to safely get increase in power of the solar system up to 50% or even higher than they are producing. Besides our main objective of a power boost, we will also achieve other benefits as well, which include life expansion of a solar panels auto cleaning, a piece of art, maximum collection of natural resources and its beneficial use.
So here we have 3 solar panels. The rated power of each solar panel is 120 watts. It makes total rated power of 360 watts. But we all know, and it is true, that solar panels will not give the same amount of rated power during summer. These 3 panels produce 190 to 200 watts during peak time.
We will do a practical demonstration of achieving the objectives. To do this, we have to arrange the solar panels with a new technique, and after that apply a new unique idea to it. I am sure this series will be very interesting. I will do magical things about solar energy in this series. So watch the complete series. I am sure a lot of unknown things about solar energy will come to your knowledge. No one will tell you about these solar techniques. I am working on this for years. So watch, share, and like the videos. Also, subscribe to the channel for more. Let's start. I have rearranged all 3 solar panels. As we can see, I have arranged all panels in vertical form and placed them side by side, making sure there is no space between them. Here you can see that 2 panels on the left-right sides are polycrystalline and 1 panel in the middle is monocrystalline. The use of 2 different types of solar panels did not cause any issues in working or performance. All 3 solar panels are connected in parallel connection. As I mentioned back, that I am making a 12-volt setup. So from parallel connection, voltage will remain the same of the array, but ampere will increase by 3 times. We made a DIY platform to mount the solar panels for a temporary period. We made 4 small pillars to lift the solar panels from the ground to some height. It is necessary to have a slope in the solar panels, otherwise the objective will not be obtained. For this slope must be downwards 25 degrees to 40 degrees. Now it is very necessary to take some safety precautions to avoid damage from the stormy winds. So due to this, panels must be made heavy enough to handle 100 km/h winds. We are going to work on some safety systems. Panels are strongly attached to the pillars and pillars must be strong and still. We use iron rods to make the structure strong and still. I am drilling 5 holes in each rod, which will be attached with pillars by screws. It will give some level of strongness to the structure. Nowhere are some short visuals of how dangerous is poor installation of solar panels. See that whole structure fall from the building due to winds. This short shows solar panels are falling from the tall building due to strong winds. In this clip, solar panels are mounted on the sun tracking structures which are not strong enough to handle the strong winds. Anyway, we come to our main project. To achieve the objective, we need an idea and then construct a system that achieves the objectives in reality. First, we see the system graphically and then we apply that system practically. Suppose these are our 3 solar panels. And then we need a water bucket. This is the 90-liter water bucket. There are different types of water, for example tap water, filtered water, bore water, rainwater. We can only use rainwater for this purpose. After a brief research, this thing comes to my knowledge that only rainwater has no issue. Other types of water cause different issues, so don't use them. We also need a water pump which is 12 volts and required minimum power, but have high performance. I will use this water pump. There are also other pumps that take even less power than this pump. This pump consumes only 8 watts. Every day this pump will operate automatically on the time which we set. It is not recommended to put water on hot solar panels, so we set the pump start time at 8 a.m. and the off time will be 4 p.m. This cycle continues for 8 hours daily. In the next part, I will first explain the complete working of the pump graphically and then we see it practically.
So the plan is we will pump the water to the top of the panels. Here another thing is needed, which is PU pipe or anything like that.
We also need a half-cut piece of PVC pipe which is used to collect water which coming downwards.
Now these are the small nozzles that plays key role in the water cooling process. I searched this thing for a week of efforts and finally I select these nozzles. The purpose to select these nozzles is because they are super cheap and do the work very perfectly. These are available in 3 forms: 90 degrees, 180 degrees and 380 degrees. I am using 90 degrees. Now water is sprayed from the nozzles from above on the solar panels and slide downwards and collected by the half PVC pipe.
Safety is the first priority. So we make sure things we are doing must be safe, environmental friendly, did not waste natural resources, and it should not cause any damage to property and solar system. Then a diameter of 1 inch, the rubber pipe is connected with the PVC pipe which again drops that water into the 90-liter water bucket. As we said back, safety is the first priority. So we make sure things we are doing should not cause any kind of damage to our solar system. The main purpose of doing these things is to get more benefits. This makes a solar panel's water cooling cycle which repeats continuously the whole day. I want to tell you a few more things. This system is built at a very low cost. It costs not more than $10 to $15, but gives a lot of benefits such as it saves the cost and space of 2 more solar panels. It also increases the life of current solar panels in such a way that these panels now work at a recommended temperature. One more amazing thing for me is that normally these solar systems are installed to collect sunlight and convert it into energy to fulfill our energy need. But now this system is performing another additional task, is to collect the rainwater, which we can use for other purposes as well. In other sense, this system is doing overtime job. That is cool. I am sure you thinking one thing, the water in the bucket will get hot and it causes no effect. Wait, let me tell you another amazing thing. I will put that water bucket under the solar panels and wind flows under and over the bucket and heat dissipates naturally into the air. In the next diagram, we will see how the rainwater collects for this purpose. This is more than enough. Just think it is a small solar system of 3 panels and applying this active cooling system, this system acts as a 5-panel system. If we calculate its benefit in percentage, it is a clear 60% more benefit. So if we suppose we have 30 panels, then applying this active cooling 30 panels system will be like a 48-panel system. Mathematically 60% of 30 is 18 and 30 add to 18 is equal to 48. It is like magic that in a 30 panels cost and area we are getting 48 panels power. Now we see how rainwater is harvested from the solar panels. Suppose these are the same solar panels. They are making an angle of 25 degrees downwards. At the bottom of each solar panel, a piece of half-cut PVC pipe is placed. We also need a water tub or water bucket to store the water for later use. Then a diameter of 1 inch rubber pipe is attached with half piece of PVC pipe and it is dropped into the water bucket. All things are set now, the only thing that is left is rain. So when clouds come and it starts raining, rainwater will fall on the solar panels and slide downwards, where a PVC pipe collects all the rainwater. Then through a rubber pipe water is transported to the water bucket. This is a very simple and very efficient way to harvest a lot of rainwater within no time. According to my calculations, these 3 solar panels occupying an area of 5 by 8 feet can fill 90 liters of water tub with 35 to 40 millimeters of rain. Which is very impressive. We are coming to the end of part 1 of this series. I am hoping you enjoyed this part. In the next part, we will transform this graphical work into a practical form. We see how this cycle works. We also do testing and see the results in reality. So must watch the next part. Normally solar systems are installed to collect sunlight and convert it into energy to fulfill our energy needs. But in this case, the solar system is performing an additional task, which is harvesting rainwater. We can harvest a lot of rainwater which we can also use for other purposes. Thanks for watching part 1 of Solar Energy series. Please like and share this video. Also, subscribe to this channel. We feel motivated by your support, so support us by liking and subscribing A-ZEE channel. Must watch these related videos. These videos are related to this topic. Thank you.